Hey, 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 everybody. Hope you're doing well. And full disclosure, it's about 7 o'clock on Saturday night when I'm actually taping this, and I actually just want to go outside. It's a gorgeous night and have a nice little fire, and so I didn't even bother making a Microsoft Word typed up sheet for you guys. I am just lazily using Mrs. Middleton's notes. I hope you could forgive me one day. We're just going to go through this. Here we go. All right, sequence and series is our new unit. It's our last unit. Oh my goodness, it's our last unit of the year. What's up? What are sequences? You're looking at two of them right here. 4, 7, 10, 13. What are we doing here? We're just adding 3 each time. Adding 3. A sequence is just a pattern of numbers or a pattern of things. 2, 4, 8, 16, 32. We're multiplying by 2 here. Over the next 2 lectures after this, we're going to focus on these type of sequences in lecture number 2 and these type of sequences in lecture number 3. Sequences are nothing more than patterns. Now, what is the definition of a sequence? It's just a specific type of function. Why is it a specific type of function? Because the domain is not all real numbers. The domain is the set of natural numbers. So what's the set of natural numbers? 1, 2, 3, ... And why is it the set of natural? Why are those the only ones you could plug in? Well, because a sequence has a first term, that's 1, you plug in 1. A second term, you plug in 2. A third term, you plug in 3, and so on and so forth. So you can only plug in the term number. And then the answer, I should say the range of the answers are all real numbers, anything that you can get out. Okay, unless there are some restrictions. We'll find that out in example 2. What is the definition, say, of an alternating sequence? It's one in which the terms alternate signs, so positive, then negative, then, and so on and so forth. The very last example of our lecture will go through an alternating sequence. Last but not least, what's the definition of a series? Because the unit is sequence n series, it's just the sum of the numbers in a sequence. So instead of putting commas in between the terms, you would put plus signs in between the terms and add them up, and that would be the series, the sum of that sequence. So nothing else. So here's a sequence. Looks just like a function, doesn't it? Because it is. The only difference is the n, what you can plug in, is just positive integers, the set of natural numbers. So we could find the first term, the second term, third, fourth, and fifth. And how do you do that? Straight up Algebra 1, yo. I'm taking you back to middle school for this. This is literally middle school stuff. So just take n and replace it with 1. So 5 plus 2 times 1. So 5 plus 2 is 7. 5 plus 2 times 2, 5 plus 4 is 9. 5 plus 6 is 11. 5 plus 8 is 13. And 5 plus 10 is 15. Those are these numbers right here. Ta-da! Done with example 1. Wow. Here's another sequence. B sub n equals 3n divided by n squared minus 1. Why is the first undefined? Notice why I said the range could be all the real numbers unless there are restrictions. Well, if I plug in a 1 for n here and n here, I get 3 times 1, which is 3, and then 1 squared, which is 1 minus 1, which is 0. 3 divided by 0 is no, undefined. Other than that, you plug in n and you will get all of these fractions. And as you see with Mrs. Middleton, make sure you reduce all fractions. That's it. As the Glade commercial that you see on TV says, plug it in, plug it in. That's it. Plug it in, plug it in. Students in my full year classes will have that little song, plug it in, plug it, jammed into their heads for the rest of their lives. You only heard it for the first time in June, so consider yourselves lucky. All right. So what is this exclamation point? Is that an excited n? Is that n? No, it's not. It's n factorial. That is how that is pronounced, n factorial. You can all say factorial. All right, not n exclamation point. What does factorial mean? It just means multiply from n down to 1 or from 1 up to n, however you see fit. As a general rule, by definition, 0 factorial equals 1. Hey, doesn't raising something to the power of 0 also equal 1? Yes. So 0 factorial equals 1. So what if your sequence is a sub n equals 2 to the n power divided by n factorial? Well, I did some on the side for you. A sub 1 would be 2 to the first power, which is 2, divided by 1 factorial, which is just 1, and your answer is 2. And there's the answer right there. If I plug in 2, that's 2 squared, which is 4. divided by 2 factorial, which is 2 times 1. So 4 divided by 2 is also 2. There it is right there. To the third, 2 to the third is 8, and 3 factorial is 3 times 2 times 1. 3 times 2 times 1 is 6, and 8 over 6 reduces to 4 over 3. And that answer is right there. Please do not overthink any of these things. It's just straight up plug it in, plug it in. Plug it in, plug it in. Okay, Glade plugins. Okay, what is the recursive formula for a sequence? It really should say recursive formula for a sequence. All right, so in other words, for a recursive formula, you need a gift. You need a term to be given already, at least one term. And in this case, a sub 1 is given to us. A sub 1 just equals 2. And then all the subsequent terms are deduced by using the earlier terms. So I want you to take a look at this formula right here. I'm going to use a different color pen for this. Okay, here is the recursive formula for the sequence. It's 3 times a sub n minus 1. What does a sub n minus 1 mean? Well, think about this. If I want to find, let me just write it down here. If I want to find a sub 2, I'm going to do 3 times, well, it's going to be a sub, what's 2 minus 1? A sub 2 minus 1 is a sub 1. That's the term previous to a sub 2. So whenever I use a recursive formula, I don't call it a sub n minus 1. I call it the previous term, PT, previous term. So that's right here. Oop. Okay, so 3 times the previous term, which is a sub 1, which is the 2, is 3 times 2, which is 6. 6 plus 2 is 8. Then watch. To find a sub 3, I do 3 times the previous term, which is 8 now. 16 plus 2, I'm sorry, 24 plus 2 is 26. Then to find a sub 4, I take 3 times the previous term, which is 26, plus 2, and I'll get 80. And then to find a sub 5, I do 3 times the previous term, which is 80, plus 2, and I'll get 242. And this sequence can keep on going forever and ever and ever. As my grandmother would say, she's a Polish grandmother, this is a pain in the dupa, because in order to find a sub 10, for instance, you have to find a sub 9, but to do that, you have to find a sub 8, and a sub 7. So there's no way that you can just find a sub 5 by plugging in 5 and getting the answer like you can with these, okay? Recursive formulas require you to find the previous terms. Last but not least, second to last but not least, okay, sigma notation. This is called sigma notation right here. I'll go back to red. Okay, this Greek letter is a capital sigma. And it's called sigma, well, it's not called sigma. You know, for you seniors, hopefully next year you'll be seeing that sooner rather than later, walking down fraternity or sorority row. It is also called summation notation. Here's how you read it. The sum as j goes from a bottom number up to the top number of a sub j, or whatever is afterwards. All right, it looks like it's all Greek. I'll be here all week, folks, because it's a Greek letter. Anyway, all it really means is you start by plugging in for j, the number on the bottom, and then integer by integer you go until you reach the top number. That's it. So here, the sum as I goes from 3 to 6 of 3i plus 2. Here is the summation notation right here. There it is. So what am I plugging in first for I? I'm plugging in 3. So 3 times 3 plus 2. Then integer by integer, I do 3 times 4 plus 2. 3 times 5 plus 2. Until I get to the upper number, which is 3 times 6 plus 2. So you get 11, you get 14, you get 17, you get 20. Do not make this mistake of just finding those 4 answers and leaving them the way they are. The Greek letter sigma means add stuff up. So add up the answers and you'll get a final answer of 62. That's really it. You go from bottom number, plug in until you get to top number, find all the answers individually, and then add them up. And Bob's your uncle. That's it. Last but not least, the only definition we haven't spoken about yet was the alternating sequence. And Mrs. Middleton, I guess, must have done number 61 from today's homework for you. Thank you, Mrs. Middleton. All right, find the series of this in summation notation. So positive 2, then negative 4, then positive 8, then negative 16, then positive 32. So let's deduce this ourselves. So first off, it's the sum, and I know she wrote I, so I'm just going to do J, just because I feel like it. 1, and there's 1, 2, 3, 4, 5, 6, 7 terms. So 7. First off, aren't we just multiplying by 2? 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth. So it would be 2 raised to the j power. Notice she used I used j. It doesn't matter. But this, what I have written here would just produce positive answers. So how do we get it to alternate? You get it to alternate by multiplying by -1. But how do you get the -1 to be positive sometimes and negative other times? And look what Mrs. Middleton wrote, to the j plus 1 power. Okay, think about that. If you want to find 2 to the first, that'd be 2 to the first, which is 2, and then -1 raised to the 1 plus 1 power. That would be -1 to the second power. Remember that -1 raised to any even power gives you a positive answer. -1 raised to any odd power gives you a negative answer. Perhaps you remember that either from your Algebra 1 and Algebra 2 days. Yeah, going in the Wayback Machine for that. Remember that? So that is why Mrs. Middleton has the answer that she has. Now, some of you clever folk out there might be asking, hey, Mr. Cody, could I have done, why is this not erasing? There we go. Could I have written instead j minus 1 to the j minus 1 power? Well, let's see. If I did 2 to the first, that's 2, and then -1 to the 1 minus 1 power, that would be -1 to the 0 power. What's anything raised to the 0 power? +1. Yeah, that'd be, so yes, it could be this, or it could be this. -1 or +1. So I hope that was helpful. It's definitely went quicker than me typing it. And I'm going to give you actually one more lesson after this. So you're going to get 2 on this one day. All right, bye everybody.